Assalamu alaikum and hello everyone. My name is Dr. Bilal and welcome to another lecture on Introduction to Programming using C++, a step-by-step approach. Today we are going to go through preprocessor directives and operators. In this lecture, we're going to see that why and what are actually preprocessor directives and why are they important to include while we are making a program, and why is it necessary that we must include those preprocessor directives before we actually make a program or we run a program. Then the next topic that we are going to see are the operators. We are going to see the different types of operators and what are these different types of operators and why are they necessary and how can we actually use those operators in our program. On the top of that, we're going to see the basic structure of C++ program, that how we can actually make one of the very simple programs. Generally, it's a hello world program. So that program, the program that we are going to actually present over here actually shows the different parts of the program. For example, the preprocessor directives and some of the preprocessor directives, plus the beginning of the program, the main body of the program, and the ending of the program. And then later on, we are going to see some of the increment and the decrement programs and some other simple programs. So let's actually start with the preprocessor directives and see what the preprocessor directives are. So the preprocessor directives are predefined libraries which contain the inbuilt programs for specific libraries. Preprocessor directives are initiated by the letter hash. So it is important that we must know that this hash is to be actually put before we actually include any of the preprocessor directives. And the libraries can also be defined to provide specific functions. Now, if we actually see some of the examples of the preprocessor directives are include IOStream. So we can see that we have actually put a hash over here, and we have written a keyword over here, include. And then within this less than and greater than sign, we have written IOStream. Now, this IOStream is one of the libraries and or the preprocessor directives. And we want these libraries actually provide the basic input output. For example, it actually contains some of the basic definitions of your cin and your cout and so on and so forth. Similarly, this conio.h is another input output header file. So we have to write it as it is. Now this .h over here represents header. So this actually is a header file. This is also a header file, IOStream, but it's not necessary that we actually write .h over here because the compiler, usually this Visual Studio that understands, it was the older compiler versions of the compiler which did not understand without .h that what IOStream is. Similarly, math.h is another preprocessor directive or a library which actually has the basic definitions of different functions like cosine or sine, tangent. You can actually have square root, I think it's sqrt, square root. Then you can actually have you can actually define the square or the power, which actually is represented by PWR. So these are different functions which are defined in math.h. Similarly, your conio.h, that is used to input output on console. Specifically, if we actually if we want to hold some of the text on the screen on your console, we need to actually use the functions like getch or getche. So these functions are actually defined within conio.h library. So if we are not going to include this conio.h, it is not actually going to enable this getch character, which is actually also known as a get character. Similarly, if we are not going to include this preprocessor directive of math.h, it is not going to recognize either of the defined functionalities like power or tangent or sine or cosine, and it is necessary to actually include this math.h if you want to actually have any of the mathematical, functionalities. So these are the keywords. All these things have are the keywords. Like get ch is actually a keyword. C in, C out is a keyword. It becomes a keyword when you include this IO stream. Similarly, if you're talking about math.h, this PWR actually becomes then a keyword if the compiler would automatically recognize what a PWR is. It represents a power, but if you do not actually include math.h over here, it is not going to actually recognize what a PWR is. So it is necessary to have the preprocessor directives, and it is necessary to have these preprocessor directives in the beginning of the program whenever we are actually developing a program. So and that actually is the top of the line. Some of the top lines would actually be your preprocessor directives, where you'd be including all the preprocessor directives or the libraries. So we're going to see this thing in the future in the slides coming ahead, that how do we actually define these preprocessor directives before we actually start a program. So then there are operators. These operators are of various types. Some of them are relational operators, some of them are logical operators, then there are arithmetic operators, assignment operators, and increment and decrement operators. So we're going to see all these kind of operators in the next slides. So starting off with the relational operator. The relational operator are used for determining the comparison or the relationship of the variable of the right-hand side to the left side. So in the flowcharts, we have been actually discussing before that wherever there was a condition, or wherever there was a decision box, that the diamond box, if you remember. So we always actually said over there that what if your age is greater than 30? So if your age is greater than 30, or maybe you can say that if your age is greater than 30, you can actually sit on a roller coaster ride, right? You can have a roller coaster ride. But if it is less than 30, you cannot actually sit in, or maybe it's 18. You can, right? So if it is less than 80 or the greater than 18, you can actually have a roller coaster ride. So this age would actually contain some sort of a value, and if this age contains a certain sort of a value, it is going to actually compare or see the relationship on the right-hand side or the left-hand side of this equation. So if your age is currently, let's suppose, 16, and 16 is stored within an age, so this is less than 18. So this actually says that you cannot actually sit in a roller coaster. But similarly, if let us assume that instead of 16, your age is 32. So this, and 32 is actually stored in this age. So this condition comes out to be true. So if this is true, the condition comes out to be true, then this means that you can have a roller coaster. So this is how it actually works. So the relational operators, they usually determine, or they make a comparison between the right-hand side and the left-hand side. So you can also say this, that what if I have two variables. For example, I have an x, which is equals to, let's assume, 10. And I have a y, which is equals to 12. And I am making a comparison that if x is not equals to y, then we need to actually do some sort of an operation over here, right? So in that case, if this is the case and x carries 10 and y carries a 12, so what we are doing is we are actually seeing a relationship or a comparison between this right-hand side and the left-hand side. Okay, right? So this is going to compare and then give a decision whether it's a true or a false. So coming up to then a relational operator again, this is how we represent the less than. This is less than equal to. This is greater than equal to, not equal to, and this is equals to equals to. So if you're writing in C++, that if you're, it's just like not mathematics, that if you say that x is equal to y, if you're going to write x is equal to y, this in C++ actually means that you're assigning this y value to the x. So if over here I have x is equal to 10 and 12 is sorry, y is equal to 12. So what I'm going to do is, if I'm going to write equals to 1 equals to over here, this actually means that I'm assigning the value of y, which is 12, to x. So this is what this assignment actually means, and this one simple equals to actually is known as an assignment operator. So don't confuse a single equals to with a doubles equals to. So if you want to actually compare your right hand side to the left hand side, it actually means that you need to actually have, for example, this is x and y. So now you are actually comparing both the sides rather than you are assigning the y's value to the x, right? So now you are comparing whether x, the value stored in an x, is equals to the value stored in a y. So if we are actually put an if over here, so this actually becomes a perfect condition. Now we're going to actually compare. Now remember one thing, that the relational operator usually are used in conditional statements. And we can actually also use them in loops, because loops also contain the conditional statements, right? So it is very necessary to understand that these relational operators are usually used with if or for or while, wherever the conditional statements or loops are used, right? So if you remember this, we're going to actually use it later on. Just keep your concepts straight so that we can actually apply those concepts later on. So remember these things. The next thing is the logical operators, and these logical operators are used to check whether the expression is true or false. Although we had actually discussed before that this thing is the condition over here that actually generates the value of the true or a false. It might be a true or it might be a false. But there are some logical operators which we are going to use on the later stages, which would actually say that whether this condition is true or a false. And these and or and not, these are the three logical operators which actually can determine as a logical operator, right? So they can actually determine that whether the expression is true or false. We are going to use it very shortly. So just keep this concept in mind, that these relational operators are basically used for the comparison between the right hand side and the left hand side, and these logical operators are used to determine whether the expression is true or false. Okay. Then there are arithmetic operators, which are like plus, minus, static, hash, and modulus. Now, this is basically your addition, this is subtraction, this is multiplication, this is your division, and this is your modulus. Now, modulus is more of a remainder sort of a thing, right? So if you want to actually find out a remainder, you can use a modulus. So there'll be certain programs in which you would be expecting to see whether it's an even number or an odd number, or maybe you may actually be required to actually calculate some sort of a remainder based on which you need to actually make some certain decision. So in that case, you're not going to actually divide anything. You can actually simply use this percentage sign to have a modulus. Similarly, this assignment operator, as I had actually discussed in the slides over here, and I had actually already discussed this assignment operator, right? So this assignment operator is over here. So the assignment operator are used for assigning the values of the variables on right hand side to the variables on the left hand side. So this is, I think this is pretty simple. I actually gave you a very simple example over here, that if x is equal to 10 and y is equal to 12. So if you say that x is equal to y on the later stages, the value of x would actually be 12. It should be stored over here because y actually contains 12. This 12s will be assigned to x. So now as a resultant of this assignment, this value of x will also become 12. So I hope this is understandable. Okay, then there are increment and the decrement operators. The increment and the decrement operators are very simple to understand. At the same time, it becomes quite tricky. So increment decrement operators are used for incrementing or decrementing in the value of the variable by 1. So if it is a plus plus, it would actually mean an increment. If it's a minus minus, it actually means it's a decrement. So for the assignment operator, if we are putting the increment and the decrement operators are actually used in two ways. One is a post-increment or the decrement, and another one is a pre-increment of the decrement. So over here, we can actually see the post-increment and the decrement. This is how we write it. We write the name of the variable, and we put a plus plus or minus minus sign at the end of the variable. So that actually becomes a post-increment of the decrement. We're going to actually see in a very short while within this lecture that what is how does this post-increment or the pre-increment actually work. So if we actually see the variable over here, there is plus plus or minus minus sign just before this variable. So that actually becomes a pre-increment or the pre-decrement. So remember one thing, that if we are actually calling out for the post increment or the decrement, this actually means that it is going to increment the variable or the value of the variable after the line has been processed, or the variable has been line/variable has been processed. Whereas over here in this is going to increment the value of the variable before processing. So logically, I'm going to rub off this whole thing. Logically, what we are saying is that this is going to increment this post increment or the decrement. It is going to act after processing. And this is going to work pre-increment and the pre-decrement. This is going to act before processing, right? So we're going to see an example by the end of this lecture. So this is a very simple demonstration of a C++ program. This is the format, or this is how we actually write the C++ program. So over here we can see that we actually have an include over here at the top. So as I said, we need to actually put the preprocessor directives or the header at the top. Then there is a using namespace. Now this is where we actually use the names of the objects and the variables from the library, and should always be come after the preprocessor directives. For example, if we have another preprocessor directive over here, that is include math.h. So we are going to write it this preprocessor directive before using namespace std, right? Because this is a standard namespace that we'll be using for after including these preprocessor directives. It is not possible that we write the using namespace std and then we actually include another variable, another preprocessor directive. Let's suppose conio.h. Sorry for the bad handwriting though. Okay. Let me actually write this include again. Okay, so this is where this is not possible. This is not possible. This is going to give you an error. Okay, so this is out of question. However, this conio.h can be defined before using namespace std. Okay, All right. So once first we actually define the preprocessor directives, then the using namespace std. Then we are going to write down the function name, which is the main function. This is where the heart of the program. This is the heart of your of your program. This is where everything actually works. For the time being, you just understand that because everything. If you're working in object-oriented programming or whatever, the main program is must. It has to be there in your C++ program. So we're going to start with the main. Over here, we're going to tell the return type. What is the return type of this main function. You can also have no return type. In case of no return type, you can actually have a void over here. In that case, you're not going to actually place return 0 over here. Okay, if you're actually putting a void over here, void main, you're not going to put a return 0 over here. Okay, so I'm going to rub it off. It's just an instruction for you. So we have a return type. Then there is a main. The main function is basically the heart of the program. It should always be defined in the program. It's not possible that that your program is without a main function. All the programs in C++ has a main function, whether it's an object-oriented or data structures or anything else, structures, or whatever you take, the main program has to be there. Then there comes out to be braces. This is where your opening body is. So every main function or every function has a body. So the body of the main function starts with the braces and ends with the braces. All right, and everything within this body is actually can actually be defined. You can actually write any processing over here. So over here, what we have written is a cout, which is an output, and then there is a hello world, which is a double quotes are used to print the string as it is. So this is a string that we want to actually print. So the output that you are going to get on the console, in case if you run this program, which I strongly recommend that whatever programs that I'm showing you in the slides, just go and write it in your C++ compiler with whatever compiler that you're using, and try these programs on your compiler to see what output do you get. So in this case, you are going to get hello world as an output. All right. So in subsequent slides, I will actually include some of the console outputs as well, so that you can actually have a better visualization. Over here, another program, again, the preprocessor directives, then using namespace std, int main. Over here, what we have done is we have defined one variable. We have initialized one variable with the type integer. So this is your data type, integer. And this is a num1 variable of data type integer. So we can actually store some of the integers over here. So then over here, we can actually see there is a cin. The cin is for the input, for the user input. Okay. So this is for the user input. So whenever you are going to actually put this cin and then greater than, and then num1 semicolon over here, it is actually going to, ask you for the input on the console. So if you have a console, right, and there's an input, there'll be a cursor blinking over here so that you can actually give an input. So let's assume I enter 270. Let's assume. So this 270 will actually be stored in num1. So now the value of num1, because I have entered 270, the value of num1 is going to be 270. This is going to get stored in num1. Now that we have actually had an input, we are going to actually cout. And the cout is the value or you entered in num1 variable is num1. Now exactly this num1, I'm not going to say it's 270, I'm going to say it's num1, right? So anything outside the quotes, if it contains any value, it will give you a value as an output, right? So it is going to print the same. If you actually go to the console and see the console, you'll be going to find out this whole string is going to get printed on the console. And then After these two colons, 270 will be printed over here. After these two colons, okay, right? It would be printed 270, right? And this is where I'm going to return my 0, which means that I'm not returning anything to the main function. And this is where I end the program. All right. So the output that we're going to get for initially, the input that we're going to get is 270, and the output will be this particular string along the output 270. So I hope this actually makes sense. Just go to your compiler, type the same program, and see what the output is, and start fiddling up the program. Try getting more variables as an input. Try defining, initializing more variables like num2, num3, maybe some float data type variables, some double data type variables, and then try outputting those type of variables, right? Okay. Another simple program is that we have a preprocessor directive on the top using namespace std int main. Now over here, I have defined more than one variables as an integer, which is a num1, num2, and result. Now this is where your addition program comes in. If you remember that flowchart, this is where your addition comes. We take num1 as an input, num2 as an input. Let's assume on the console, we actually get initially one input. For example, it's I enter 15, and for the num2, this 15 is going to actually get stored in num1. So num1 is 15, and then another cursor over here would actually be blinking, and then I enter, let's assume 20 over here. So this 20 is going to get stored in num2. So the value of num2 would be 20. Now that I have actually 15 and 20 over here, which are been assigned to their respective variables. Now what we are doing is we are going to add num1 and num2. So if we add num1 and num2, this means that I'm adding 15 with 20. Okay, right? So this 15 plus 20 is 35. So this 35, 15 plus 20 is 35. Now this 35 is going to get stored over here in the result, because whatever resultant that we are going to get out of the addition of these two variables will actually be stored in the result, because there is an assignment operator over here. Okay, so now the result is actually, sorry, my bad. The result is equals to 35. So this 35 is going to get stored over here in the result. So now we see out the result of addition is a result, which is basically 35. So this 35 is gonna get printed just after this equals sign on the console. All right. So this is another very simple program. So just go back, make the same program if you want to. Just try taking initializing more variables. Try taking input of more variables. Try adding, subtracting, multiplying, maybe those variables, and then get an output. All right. So you can actually practice on your console. Compiler. This is another program for the increment and decrement. Now that we had actually discussed increment and decrement over there, and I had actually discussed two different things. One was your post increment, and another was post and pre. So within the post, I had post increment and post decrement. Similarly, for the pre, it was pre-increment and pre-decrement. So in case of this, I said this would be actually done after processing, right? And this pre will be done before processing. So let's see that what does that actually mean. after processing and before processing. So let's actually see. What I've done is I'll just go through this program first, and then I'll actually I'll demonstrate that how this increment and decrement actually works. So it's a preprocessor directive using namespace std int main start of the program, and then I initialize two variables, which is a num1 of the integer type, which has been assigned a 10 into num1, and then there is a num2 which has been assigned 5 in num2. All right, so the value at this point of time, I've actually made two variables now. So one is num1 and another one is num2. So at this point of time, num1 contains the value 10 and num2 contains the value 5. Okay, so this output over here says C out num11 plus plus. So this is a post increment. Then there is a num11 plus one plus plus num11, which is a pre-increment. Then there is a num1 minus minus post decrement. This is your pre-decrement, right, with the num2. And then what I've done is this is your pre-decrement, and which has been assigned an pre-decrement of num1. So this actually says that the pre-decrement of num1 actually has been assigned to pre-decrement of plus increment of num2. And then the C out of plus plus num2. I understand this actually becomes a little bit confusing, but it will not remain confusing. Just listen to it very carefully. So what we are doing over here is this is your post increment. Okay, so right now, what did I say? That being a post increment, we are going to actually see after processing. Whenever it's a post, it's after processing. Okay, so this means whenever this line has been processed, this variable is going to increment. So in this particular case, because it is output, right? So within this output, this is going to give you the value 10, right? So let me draw the line over here, and the output actually starts from here. So it is going to give you an output of num1 of 10. Once it has actually printed the value of 10 over here, it is going to, now that is processed the statement, it has actually printed this 10 value over here on your console. Now this variable is going to increment. All right, so initially it is going to print 10. After that, num1 is going to increment. Now that it has incremented after it has printed, now logically this num1 plus num1 actually contains the value 11, not 10, because after the printing of 10 and the processing of num1 variable, this value has been incremented, or the variable has been incremented. So from 10, it is going to increment to 11. Okay, right? So in the next statement, when we actually say pre-decrement, because it is pre-decrement, it is going to go for the before processing. So before processing actually means that if the processing, we are calling C out as a processing, or the generating an output as a process or processing, right? So this means that before printing or before giving a certain output, it has to get incremented. This num1 has to get incremented. So right now, what does this num1 contain? This num1 contains actually 11. Okay, right? So before printing, because in the last statement, after printing, it had actually incremented from 10 to 11. Now this num1 is actually going to increment it before the printing, before it has been processed or pre-processed, right? So now it is going to print. It was 11. It is going to increment it before it gets printed. So it is going to actually print not 11. It's going to print 12. So now that the num1 over here has been actually incremented as a pre-processing, it is going to generate 12 instead of 11. All right. See, is this understood? So now, in the next statement, it again says post-decrement. So post-decrement means after processing. So it is going to print 12 again. Why? Because num1 currently carries 12. Okay, right? Because it actually carries 12, it is going to print 12 as it is. All right. And then it is going to decrement it. So once it has actually decremented, it will actually decrement it to 11. All right. So now num1 actually contains 11. In the next statement, it's num2. And when num2, it is actually a pre-processing, right? So pre-decrement, sorry, right? So that actually means it's before processing. So before an output, it is going to decrement it. So num2 right now actually has 5, right? So it is going to actually decrement it, and decrementing it would actually make it 4. And it is going to give you on console an output of 4. All right. And after that, this statement that plus plus num2 equals to minus minus num1. So this num1 currently has the value 11. Okay, right? It currently has the value 11. Now, 11 over here would actually be pre-decremented and then assigned to the num2, which is pre-incremented. So over here, we are going to have two pre-increment, and on this side, it's a pre-increment, and this on this side, this is a pre-decrement, right? So num1 is going to get a pre-decrement, and num2 is going to get pre-increment. So num2 at this point of time is 4. All right. Num2 is 4. We had actually seen it as a 4. So num2 being a pre-increment is going to become 5. Okay. And but num1 over here is, because it is 11, it is going to become 10. Okay. And because this is a pre, it is going to decrement as well as increment before num1 is assigned to num2. All right. So once it is decremented, it is going to actually assign num1 to num2. So logically speaking, we had actually got 5 over here, and we had actually got 10 over here, right? So we are going to assign num1 to a num2, because after this pre-decrement, the value of num1 was 10. This 10 value is going to override the value of 5. So num2 is now going to become 10. All right. And then after that, what we are doing is we are saying C out plus plus num2. Now over here, it is again a pre-increment. So before it actually prints, because the num2 has the value of 10, now it is actually going to print 11. That's right. So we're going to have 11 as an output. Okay, so I hope this pre-increment, I've tried simplifying the pre-increment, the pre-decrement over here. So I hope it's understandable. If you have any questions regarding this pre-increment or the pre-decrement, or even if incrementing or decrementing, you can actually straight away email me or contact me in my office. This is my email, and this is my website. So if there are any queries, please do let me know. Thank you so very much for this lecture.